You try to tell a story to your phone, but it forgets the beginning by the time you get to the end. What's going on? This is a big problem in AI, and it's called the long sequence problem. You see, AI models are really good at understanding short sequences, like a sentence or two. But when it comes to long sequences, like a whole story or a conversation, they start to forget. Let's explore why this happens. Imagine you're trying to remember a long list of items. You can remember the first few items, but as the list gets longer, you start to forget. This is kind of like what's happening with AI models. They have a limited amount of memory, and when they try to process long sequences, they start to forget the earlier parts. But why does this happen? Let's think about it like a game of telephone. You know, where you whisper a message to someone, and they whisper it to someone else, and so on. By the time the message gets to the end, it's usually completely different from the original message. This is kind of like what's happening with AI models and long sequences. So, let's break down what's happening with AI models and long sequences. You see, AI models use something called recurrent neural networks, or RNNs, to process sequences. RNNs are like a loop of neurons that keep passing information to each other. But the problem is, each neuron can only hold a certain amount of information, and when the sequence gets too long, the information starts to get lost. This is called the vanishing gradient problem. It's like a game of telephone, where each neuron is whispering the message to the next neuron, but the message gets distorted as it goes along. To fix this problem, researchers use something called long short-term memory, or LSTM, networks. LSTMs are like special neurons that can remember information for a long time, even when the sequence gets really long. Let's see an example of how this works. Imagine we're trying to predict the next word in a sentence. We can use an RNN to process the sentence, one word at a time. But when the sentence gets too long, the RNN starts to forget the earlier words. To fix this, we can use an LSTM network. The LSTM network can remember the earlier words, even when the sentence gets really long. Let's see how this works in practice. We can use a tool like TensorFlow to build an LSTM network and train it on a dataset of sentences. Then, we can use the trained network to predict the next word in a sentence. Let's see how it does. So, why does this matter? Well, it matters because AI models are being used in all sorts of applications, from language translation to chatbots. And if these models can't remember long sequences, they're not going to be very good at their jobs. But with LSTMs and other techniques, we can build AI models that can remember long sequences and do a much better job. For example, we can use LSTMs to build chatbots that can have long conversations with users, without forgetting what was said earlier. Or we can use LSTMs to build language translation systems that can translate long documents, without losing the context. So, let's recap what we've learned. We've learned that AI models have trouble remembering long sequences, due to the vanishing gradient problem. We've learned that LSTMs are a solution to this problem, because they can remember information for a long time. And we've learned that this matters, because AI models are being used in all sorts of applications. Here are the key points. Asterisk AI models have trouble remembering long sequences. Asterisk LSTMs are a solution to this problem. Asterisk this matters, because AI models are being used in many applications. Next time, we'll explore how AI models can learn from data, and how this relates to the long sequence problem. We'll see how AI models can use techniques like backpropagation and gradient descent to learn from data. And we'll see how this can help AI models remember long sequences, even when they're not using LSTMs. Don't forget to subscribe for more AI lessons, and we'll see you next time. Thanks for watching, and we'll catch you in the next video.